This SOS video lesson is on linear equations that are not solved for y, but we can still graph them. We need to remember certain vocabulary. Inverse operations are operations that undo the effect of each other. So if I add a number to undo the effect, I will subtract the same number. If I multiply by a number to undo the effect, I will divide by that same number. If I isolate something, I get it all by itself. And a solution set are all the answers that make an equation true. So in order to graph a linear equation, we need to isolate y by using inverse operations. In this video, we're going to use a table of values to show some of the ordered pairs in the solution set that we will graph. So let's take a look at the first linear equation. It says 3y equals 6x minus 12. We haven't isolated y yet. To do that, instead of multiplying by 3, I'll use the inverse operation of dividing by 3. And whatever I do to one side, I need to do to all the terms on the other side. Division, property of equality. 3 divided by 3 is 1, so this is 1y, equals 6x divided by 3 is 2, so we have 2x. Negative 12 divided by 3 is a negative 4. I take a look at the coefficient of x, which is an integer. And when I have an integer, some of the x values I like to use are a few negative ones close to the origin itself with 0, and a few positive ones. Let's put the y output values here. We can do this mentally and replace the x variable here with each x value. So when I replace x here with negative 2, 2 times negative 2 is negative 2, negative 4, and a negative 4 and another negative 4 is a negative 8. When I replace this with a negative 1, 2 times negative 1 is negative 2, minus 4 is negative 6. When I replace x with 0, 2 times 0 is 0, minus 4 is negative 4. When I replace x with 1, 2 times 1 is 2, and a positive 2 and a negative 4 is a negative 2. And when I replace x with 2, 2 times 2 is 4, and 4 minus 4 is 0. What we can also do before we graph is let's make sure that this table of values does match what we have written in our calculator. So I look at my display in my calculator, I go to y equals, and I type in what I have here. If you already have something written down in y equals like this, just move your arrow to where it is, press your clear button, which is right below your arrow keys, and that'll make it disappear. Right, we're going to type in y equals 2x minus 4. So 2, the x key is right by the alpha key, x minus 4. Remember to press the minus sign. And now we want to see if the table of values matches. So I look right above graph and it says table in blue. To get that, I'm going to press the second key and that button, and I see a table of values. And then I make sure that it matches the table of values I have here. So when x is negative 2, is y negative 8? Yes, it is. When x is negative 1, is y negative 6? Yes, it is. When x is 0, is y negative 4? Yes, it is, and so on. So we know for sure our table of values is correct. Let's put your calculator to the side and graph this. First step we do is label your axes y and x. We're going to graph each individual point. We always start at the origin. Our x values tell us if we're going to go to the left or the right. If it's negative, we go to the left. If it's positive, we go to the right. So negative 2 tells me to move to the left 2 times. The y value tells me to go up or down. If it's positive, I go up. If it's negative, I go down. This is a negative 8, so I move down 8 spaces. And I put a dot. Negative 1, negative 6, start at the origin, move 1 to the left, and then I move 6 down. Okay, stop the video. You're going to finish graphing the rest of this, start it again, and see if you did it correctly. Let's see how you did. Did you remember to connect all these dots and extend the line? Did you remember to put arrows at the end of the line? And very importantly, we need to label this line. So we go back to our original equation and write it somewhere next to the line. You can write it by the arrow or alongside the line itself. All right, let's get ready for the next one. This equation also doesn't have y by itself, so we need to get it by itself. I look on the side that has y, and I get rid of what's furthest away from this. So instead of a positive 2x, I'm going to do the inverse operation, negative 2x. Whatever I do to one side of the equation side, I'm going to do on the other side. 2x and negative 2x is a zero pair. I have negative 4y equals, well, these are unlike terms, so I'm going to write the one with the variable first, and then minus 4. To get y by itself, instead of multiplying by negative 4, I'm going to divide by negative 4. Whatever I do to one side of the equation, I'm going to do to all the terms on the other side. Division, property of equality. A negative 4 divided by negative 4 is a positive 1, so this is 1y. A negative 2 divided by negative 4, well, negative divided by negative is a positive, and 2/4 reduces to 1/2. So we have 1/2 x. And finally, negative 4 divided by negative 4 is a positive 1. I take a look at the coefficient of x, and I realize that's a fraction. So that means I should pick x values that are multiples of the denominator, so that my y values will be an easy integer to graph. So I'm going to take a few negatives, negative 4, negative 2. We'll have 0 and a few positive even numbers 2 and 4. So we can substitute this in and get our y values. You can also go to your calculator. Okay, I'm going to go back to y equals. I'll get rid of this by pressing the clear button. I need to put in 1/2 x plus 1. So we're going to press alpha y equals. To get our fraction, we want numerator over denominator. That's a 1. I go down to the 2. I move to the right. We have x plus 1. Let's get our table of values. Second graph for the table. And I go to where x is negative 4. You might have to move your up arrow to get to that. When x is negative 4, y is negative 1. When x is negative 2, y is 0. When x is 0, y is 1. When x is 2, y is 2. And then finally, when x is 4, y is 3. Okay, now that we have our table of values, let's graph this. You're going to pause the video, graph this, and start the video again and see how you did. Okay, let's see how you did. Did you remember to label each of the axes? Did you plot those 5 points, connect them, and extend your line all the way through on the plane? Did you remember to put arrows? And can you think of what other detail we still need to write on our line? That's right, the equation. We usually write your original equation, so 2x minus 4y equals negative 4. If you forget and you write your simplified equation, that would be okay too. All right, let's take a look at our last question. Claire says the solution sets to 12x minus 3y is 15 and y equals 4x minus 5 are the same. Do you agree or disagree? Justify your response. So we have to do two things. We have to say, do we agree or disagree with Claire? And we have to show why we agree or why we disagree. So what I'm going to do to make it easy to compare these two is I'm going to set this equal to y. So I have 12x minus 3y equals 15. I look at the side that has y. I'm going to get rid of the thing furthest away from it, which is a positive 12x. I subtract 12x from both sides. That's a zero pair. I have negative 3y equals, well, these are not like terms, so I'm going to write it with the variable first, negative 12x, and a positive 15. Then to get y by itself, instead of multiplying by negative 3, I'll do the inverse operation and divide by negative 3. And I need to do that to all those terms. Well, negative 3 divided by negative 3 is 1, so we have 1y. equals negative 12 divided by negative 3 is a positive 4, 4x, and a positive 15 divided by negative 3 is a negative 5. And I realize that the simplified version I got is exactly the same as the other one I was going to compare it to. So would the solution sets be the same? Yes, it would, because in the end, it ends up being exactly the same equation. Do we agree or disagree? I agree with Claire. And justify means I can show work to prove that. And the work I showed is that I took the first equation and I simplified it, and it looks exactly like the second one. So the solution sets would have to be the same. This is another SOS video.